Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Enjoy! So we need to first of all understand what a cube number is. So a cube number is the answer to when you get three integers or whole numbers and we multiply them by themselves three times. So 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, and 5 times 5 times 5 is 125. So 1, 8, 27, 64, 125 are all cube numbers, and it goes on forever. And this question's asked us to find all the odd, or an odd, cube number that is smaller than 100. So it has to be odd, so that gets rid of the 8 and the 64. And it has to be smaller than 100, so that gets rid of the 125. So I can either write down 1 would be a fine answer, or 27. I'm going to go for 1. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward 1 and have that 5 at the end. So the smallest odd number is 3,485. So what this means is that the width is between 1 and 2. So we're going to look at our list and see all the widths that are between 1 and 2. This bit here means it can equal 1. This bit here means that 2 would go to the next group. So we've got 1, 2, 3, 3 numbers that are between 1 and 2. So the frequency will be 3. This next group says between 2 and 3. So this will be 1, 2, 3, 4, 5. Then we've got between 3 and 4, just this one here. And then between 4 and 5, we have just the 1. When we simplify a fraction, we want to try and make the numbers at the top and the bottom as small as we can. So looking at the numbers 24 and 60, we need to think, is there a number we can divide both numbers by? Well, they're both even numbers, so we can divide them both by 2. And that will get us 12 over 30. These are also both even numbers, so we can again divide by 2. And that will give us 6 over 15. Now 6 and 15 are both in the 3 times table, so we can divide them both by 3. And we get the answer of 2 over 5. Now 2 and 5, there's no numbers that go into 2 or 2 and 5. And so that is our answer. Now we could have gone straight from the question to the answer by dividing by 12. And some of you may notice that 24 and 60 are both in the 12 times table, so you could have gone straight there, but it makes absolutely no difference if you divide by 2, then divide by 3, or you could have divided by 2, then divided by 6, or done it in any of those orders. The key says that a circle represents 8 DVDs, and if we cut it up, then each quarter represents 2. So Monday had 8 and 2 and 2, which is 12. Tuesday had 8 and 8, which was 16. Wednesday had 8, 2, 2, 2, which is 14. And Thursday had 8, 8 and a quarter, which is 2, which is 18. But with a pictogram, you can actually just look to see which has the most of the shape. So if you look at Thursday, it has 2 and a quarter. Well, that's more than any of the other ones. All the other ones have 2 or less. So it's definitely going to be Thursday. The key says that a circle represents 8 DVDs, but if we cut this into 4, each quarter represents 2. So we're looking to see how many DVDs were sold on Wednesday. So that would be 8 for this one. And then it's 2 per quarter. So 8 plus 2 is 10, plus 2 is 12, plus 2 is 14. So the answer is going to be 14. This coordinate is telling us to go 2 to the left from the centre. We go right when it's positive, we go left when it's negative, so it's 2 to the right. And then it's telling us to go 1 up. It's up because it's positive. So we need to go 1 up, and we get to the coordinate of B. So the coordinate we get to is B. And so we just look at the -2 on the x-axis and the 1 on the y-axis, and that is where point B is. So a prime number is a number that is only in the 1 times table and its own times table. So 4, for example, is not a prime number because it is also in the 2 times table. 6 is in the 2 times table. 15 is in the 3 times table. 21 is also in the 3 times table. 9 is also in the 3 times table. Now 1 is a bit of a special case. The definition is that it has to be in 1 and its own times table, and technically 1 is only in one of those. So 1 is not a prime number. The smallest prime number is actually 2, but 2 is not in this list. 23 though is not in any other times table, so 23 is a prime number. To find the fraction of an amount, what we do is we divide by the bottom of the fraction and we times it by the top of the fraction. So the first one we're going to do is 100 divided by that 5, and that would be 20. Then we're going to get that 20 and we're going to times it by the top of the fraction. So 20 times 4 is 80. So our answer will be 80 centimetres. Whenever we multiply two negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. So we're going to start off by working out what 100% of 120 is. Well, that's obviously just going to be 120. And we're trying to get to 6%. So we always start off by working out 10%. It's always normally useful. And we just divide that 120 by 10, so we get 12. And we try to get 6%, so it'd be nice if I knew 5%. And 5% is nice and easy because we just halve that 10%. So that'd be 6. And if we got the 1% as well, we can get to the 6%. So to find out what 1% is, we just divide the 10% by 10 and get 1.2. So to get the 6%, we're going to add the 5% and the 1%. So we're going to add the 6 and the 1.2. And so we just do 6 plus 1.2, which is just going to be 7.2. And that's our answer. So if we just add the amount of sides each of these shapes has, a triangle has 3 sides, quadrilateral 4, pentagon 5, hexagon 6. And notice what's happening with the number of edges. They're multiplied by 3. Each time they're multiplied by 3. So all we need to do is get the 15, multiply it by 3, which will be 45. So there will be 45 edges. Something to realise in this table we're given in this question is that the triangle has 3 sides, quadrilateral 4, pentagon 5, and hexagon 6. And that number is just 2 less than the number of faces. So basically, if you've got the number of sides, you add 2. So 4 plus 2 is 6, 5 plus 2 is 7, and 6 plus 2 is 8. So if we've got 20 sides, and we just do the same thing, so we're just adding 2, then we should have 22 faces. So our answer is 22. When a number is next to a letter, we actually have a times sign there. So I'm going to rewrite this question as 4 times A times 9 times B. What I'm going to do is put the numbers together. So 4 times 9, and then put the letters at the end. Now 4 times 9 is 36. So it would be 36 times A times B. And in algebra, we don't put the times signs. So it's 36AB. To To multiply fractions, all you need to do is multiply the tops. 3 times 7 is 21, and multiply the bottoms. 4 times 11 is 44. We see whether we can simplify this, but actually there's no number that goes into 21 and 44, so it's 21 over 44 is our answer. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So we've got to first of all work out how many parts there are altogether. So oil has 21 parts, vinegar has 5, so altogether there's 21 plus 5, which is 26 parts. Now, how many of those parts are vinegar? Well, vinegar is the second one, so it's going to be this 5. So vinegar has 5 out of the 26 parts, or a fraction would be 5 over 26. So to do this question, you just need a piece of paper, a ruler, and a protractor. And the first thing we do is we draw the 11 centimeter line. And my one will not be 11 centimeters for you. It is on my screen, but because depending on what device you watch this on will change obviously its length. And what I'm going to do is I'm going to put my protractor on this end here. So I've kind of got my protractor here. And I'm going to just have a look at getting 39 degrees. Now you've got to be careful because 39 is on the inside, and I'm just going to do a dot. So always look to see which one, the inside or the outside of the protractor, starts at 0, and the inside should start at 0 from this side. And I'm just going to draw a line that connects the end of that line and the dot. Like so. Now just you can keep it going. Right, the next thing I'm going to do is put my protractor on the other side. So my protractor is kind of here, and I'm lining up the crosshairs with this point here. But this time I'm measuring on the left hand side, and I'm looking at 59 degrees, which will be here. Get my ruler. Now this time I can actually stop where it hits the other line. So keep going and then stop where it hits the other line. The screen's not perfectly calibrated, so it's difficult to do precise work, something like that. And then what you can do is you can get your rubber and just rub out the extra bit of line that we had to do. And so this is our 39 degrees here, and you don't need to label this on the diagram, but just so we know what we're doing. And it says when it's completed, measure length x. So I'm going to get my ruler out and I'm going to measure this length here, this one here, and it is about 95 millimeters. So the answer for me is 95 millimeters. Now there is some level of precision. You're not going to get necessarily exactly 95 millimeters. When we mark these questions, we normally have an overlay and we put it over the top, and if it's roughly the same, and you can make small errors because nobody's perfect, and my diagram definitely is not perfect, but there are allowable small errors here and there. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first two sticks, the actual combined distance of them, So when we add them together, so be 19 centimeters plus 37 centimeters is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the two lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. To be able to add or subtract fractions, we must make the denominators the same. So what we do is we write out the 5 and 7 times tables. So 5, 10, 15, 20, 25, 30, 35. And you keep going through each times table until you get to a number that's the same in both. You can see it's 35 here. So we're going to times top and bottom by something to make the denominator 35. So for this first one, it's going to be 7. So we're going to times top and bottom by 7. For the second one, it's going to be 5. So 2 times 7 is 14, and then the bottom will be 35, the denominator. And then 2 times 5 is 10, and the denominator will be 35. Then when we have that, we take away the numerators. So 14 take away 10 is 4, and that just leaves 4 over 35. So we can see whether we can cancel it, and we can't. So the answer is just 4 over 35. Let's rewrite this expression, but with a time sign in. So v times w squared. Now w squared just means times by itself. So we can rewrite that as v times w times w. Okay, so we know v is minus 10. So minus 10. And we know w is minus 4. So it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first, and I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive, 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. So I think about ratios as piles of money sometimes, and here we've got J getting 5 piles of money and Anne getting 4 piles of money, and each pile is going to be equal. So we've got to first of all work out how many piles of money there are. So we just add the 5 and the 4, so there's 9 piles of money. We sometimes in maths call them parts, so we say that we have 9 parts, okay, or 9 piles of money. Now, each part, oh, I've got an equals there, each part, or each pile is going to be worth what 99, okay, which is the total amount of money, divided by how many equal piles we have, so divided by that 9. So 99 divided by 9 is 11. So one part is worth £11. So J has 5 piles of £11. So J has 5 times 11, which is 55. And Anne has 4 piles of that money. So 4 times 11, which is 44. We can check this by adding the two together, and it should add up to the amount of money we have, which is 99, which it does. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the centre, that's a diameter. If you've got a line just going to the centre, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. When we estimate, we normally round to one significant figure. So what I'm going to do is just rewrite this question, but rounding everything to one significant figure. But I'm just going to miss out this square root for now. So 3.3 would just be 3, and 4.7 would just be 5. Now, the problem with this 27 is square rooting 27 is difficult, especially without a calculator, and estimating should be done without a calculator. But if I round it to the nearest significant figure, if I round it to one significant figure, that will make it 30. Now 30 is no easier to work out. So square numbers are a bit of an exception. When you've got square root, it's a bit of an exception. You've got to find it to the nearest square number. So 27 to the nearest square number is 25. So square root of 25 is 5. And then 5 take away 3 is 2, times 5 is going to be 10. So our answer is 10. The experimental probability is the successful outcomes divided by the total number of outcomes. So we're looking for the probability that it's white, so it's going to be 25 over, and we're just going to do 35 plus 25 plus 31, which is 91, and that's our probability, 25 over 91. Be careful when it say total, you must include all of the outcomes, so red, white, and other. Mode just means the most common or most frequent, and modal is exactly the same. It's just the most frequent amount of coins we're looking for. So the students who had 3 coins in their pockets came up 15 times. Students had 4 coins in their pocket, well, there were 16 of them. There were 15 students who had 5 coins, 17 students who had 6 coins, and 12 students who had 7 coins. So the most frequent amount of coins a student has in their pocket will be 6, because it happens 17 times, which is more than any other amount of coins. So we start off by working out what 100% of 240 is. Well, that's obviously going to be 240. And nice easy one to start off with is 10%. And we're trying to get to 21%, so 10% is always a good one to start with. So we divide by 10, which would be 24. And because we try to get to 21%, we'll need to find out what 1% is. And 1%, we just divide the 10% by 10 again, so it would be 2.4. And then we need to find out what 20% is. And 20%, we just double the 10%, so it would be 48. And so 21% is this plus this, because 1 plus 20 is 21. So we add these together, so 2.4 plus 48. Probably don't need to do this formally. Probably do this in our heads. So 50.4, but it says to increase 240 by that amount. So we need to get 240. We need to add the 50.4. Probably, again, don't need to show the working out for this. We can do this in our heads, but it's a bit easier to see what we're doing. So the answer would be 290.4. So we've got to first of all work out how many parts there are altogether. So we're told that the ratio of red, yellow and green is 3 to 2 to 4. So to work out how many parts there are altogether, we do 3 plus 2 plus 4, which is 9 parts. So there's 9 equal piles of sweets. Okay, but to work out what one part or one pile of sweets is worth, we're going to get the 99 sweets and divide it by the amount of piles, and that's going to be 11. So one part is worth 11 sweets. We're asked to find out how many yellow sweets, and yellow is the middle one, so it's going to be the 2. So yellow has 2 piles of 11 sweets. 2 times 11 is going to be 22, so it's going to be 22 sweets. I'm going to start by working out what the building is, or the width of the building is, in centimetres. So it says 33 metres, and I'm going to convert that into centimetres by timesing by 100. Okay, Now when it says it has a scale of 1 to 300, it means 300 in real life is 1 on our map. So all I need to do is divide it by 300 to find out what it's going to be on our map. So we'll just divide that by 300 and I get the answer of 11. So it's going to be 11 centimeters on our map. A plan is a view that you would get if you were on top of the shape. So you were in an airplane or something looking down on the shape. So the sides of this that we'll see, well, we'd see this bit here and we would see this bit here. So I'm going to start off with the first bit I shaded, and we've got to figure out what the different lengths will be. Well, this would be 2 centimeters across, and the whole thing is 8 centimeters. The bit we don't want is 3 centimeters, so this part here will be 5. It would look like it was 5 wide. So let's draw that on, and so we've got 2 centimeters down, and we've got 5 across. 1, 2, 3, 4, 5. And this is what it would look like from above. Now the other part will be same 2 centimeters, but it will be 3 centimeters across. So we have 3 centimeters across. Now whenever you have a join or a change in elevation, you need to show that with a line across. And so this will be our completed answer. So the question asks us to work out the bearing of the cinema from the train station. So from the train station means we're at the train station and we're looking at the bearing, which are always from north going clockwise, of the cinema. So it's this one here. To be able to do that, we need to remember a few bits about parallel lines. So we've got a parallel line here and here, and all lines point to north are always parallel, and these angles make a kind of C with the parallel lines. And we need to remember that they are interior, allied, or co-interior, depending on how you say it, but they are interior angles. And what we know about interior angles is that they add up to 180. So we're going to call this x, and we're going to say x equals 180, take away the 98 there. And so we just put on our calculator, or do it in our head, 180 take away 98, and you get the answer of 82. So we know that this angle here, instead of x, we know it's going to be 82. But the way we show bearings is with 3 digits. So it's going to be 0, 8, 2 degrees. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. So for this question we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around and it could be distorted, but it basically goes down to a point along here. It goes to infinity and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. To find out what the value of x is, we first of all have to find out what the value of y is. And we can notice that we've got two sets of parallel lines here, and a line going through them. And we kind of got these f angles, which we have to call corresponding angles. So we know that 2y minus 50 is equal to 78. And we must write down the reason, so corresponding angles. And corresponding angles are equal. Now here we've got an equation and we want to solve it, so we get our lines in. We'll go first of all, add 50 to both sides. So we've got 2y equals 78 plus 50, which would be 128. And then we're going to halve both sides, or divide by 2. So we've got 64. So we know that y is 64. And so we look back at the diagram to find out how we'd work out x. Well, what we can do, there's a few different things we can do. We could work out the fact that these two here are vertically opposite. That would be absolutely fine. But actually, if we look at this part here and this part here, these are also two parallel lines, and we've got this angle here and this angle are going to be alternate. So I can write that down here. So angle ECB is equal to 78 degrees. So this will be 78 degrees. And the reason for that is alternate angles. And then finally, if we know this is 78 and we know that this is 64, because we know what y is, then we can work out what x is. So x equals 180, angles in a triangle, take away the 78 we know and the 64 we know. And the reason for that is angles in a triangle add up to 180 degrees. And just make sure you write down all the reasons as you go. And when we take away the 78 and the 64 from 180, you get 38. So x is therefore 38 degrees. To find the pressure, we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimeters squared. And the force is given to us in the question, so what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. So we're going to start just by writing this out. So m equals 7 brackets x minus 10. And we're going to put our solving lines in. I'm going to start by expanding the brackets. And we don't need to. We could divide both sides by 7, but I think this is a bit easier. And we're going to subtract, or we're going to add 70 to both sides. So we're trying to get x as the subject. So we're trying to get x on its own. And we're next going to divide both sides by 7. So we have m plus 70, all of that over 7 equals x. So x equals m plus 70 over 7. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So the rules of indices state that if you have a power inside and outside of a bracket, we just multiply them together. So it's 10 to the power of minus 12 times minus 12. Two negatives make a positive, and 12 times 12 is 144. So factorise means to put it into a bracket, and it looks like it's a quadratic here, but it's actually just a linear factorising. Because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10. And that will leave 2 and 3. So that's the numbers done. Next, I'm looking at the t terms. So we've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally, I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now, always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30 times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the two numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So angles on a point add up to 360, and we are given the values of the angles but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together, and so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. There's a very specific way to draw an angle bisector, and you start off with a pair of compasses and put the point on B, and then draw an arc from B. And it doesn't matter what the distance is, as long as it's kind of roughly maybe halfway between A and B. It doesn't matter what the distance is. And then at the 2 points, so here and here, that our arc intersects line AB and BC, we're going to draw another arc up here. So I'm just going to show you because it's normally easier. So an arc over here, and I'm going to do an arc from the other one over here. Then what I'm going to do is I'm going to join where the two lines join with where the two arcs join. And that is how you do an angle bisector. All of the arcs leave on the diagram because they are going to get you the marks. Arcs for marks. So our triangle says that speed equals distance over time, and average speed is the total distance over the total time. So when we're looking for average speed, we want to work out, so we're just going to write average speed or speed, and it's going to be the total distance. So the distance starts at 0, goes up to 30. So the total distance is 30, and the time starts at 10:15 and ends at 11. So that'll be 45 minutes, or, well, we should do it in hours, because the units we want in hours. So it would be 0.75. So 30 divided by 3/4 would be 40. So it's going to be 40 kilometers per hour. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. 990. Now when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. There are a few different ways you could answer this question. I'm going to do it with a tree diagram, but you didn't need to draw a tree diagram to answer this question. So we've got our first tree, which is our first bus, and the choices are male and female. And we've got our second kind of branch, I suppose, and it's still male and female. And this is our second bus. So the property of male on a first bus is 9/15, and therefore the property of female is 1 minus 9/15, which would be 6/15. Male on the second bus is 7/15, and so female would be 8/15, because they need to add up to 1. And it's independent, so these will be the same. And the question is basically asking what is the probability that both will be female. So to have both female, we need to have gone down this line at the start and then this line again. Okay, so looking at the fractions along the way, it's 6/15 and 8/15. The word "and" in probability means times. So whenever you're finding the probability of getting to an outcome, so this outcome will be FF, because they're both female, you are multiplying the fractions that you go across. So it would be 6/15 times 8/15. So 6 times 8 is 48, and times the bottoms, 15 times 15 is 225. Now you can actually cancel that down. So what you can do is you can divide top and bottom by 4, and that will give you 16. Is it 4? No, you can divide top and bottom by 3, and that would be 16 over 75. So either 48 over 225 or 16 over 75. To add column vectors, all we need to do is add the tops and add the bottoms. So 3 plus 7 is 10, and 4 plus minus, or just 4 minus 5, is minus 1. So our answer is 10 minus 1. So we're asked to go from B to C and name the vector. So we can't go directly from B to C because we don't know the name of that road. So we've got to go from B to C just going down roads that we know. Well, we know the name of this road, and then we know the name of this road. Now that first road is going to be A, but we're going the wrong way up it. So it's actually going to be minus A. And the second road we went down is just B, and we're going with B, so it's a positive B. Now you could write that as B minus A as well. So here we're given a right angle triangle, and the question involves two lengths and angles, so we know we're going to be using trigonometry. So let's start by labelling our sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now notice the hypotenuse doesn't have a number or letter next to it, so let's get rid of that. Next thing we do is draw our trigonometry triangles. So we've got SO, Ca, Toa. Now we've crossed out the H, so we're not going to be interested in the SO or the Ca. So it's going to be Toa. Toa is short for tan the angle equals opposite over adjacent. The angle is 60, so it's tan 60 equals x over 1. And so now here we're looking for the exact value of x. So if I times both sides here, let's just get our solving lines in here, and times both sides by 1, or just get rid of the fraction, we end up with x equals tan 60. Now you need to know off by heart what tan 60 is, and we can work it out just briefly by drawing a right angle triangle, sorry, not a right angle triangle, an equilateral triangle. So that is going to be 60 by 60 by 60. And we're going to put all the lengths around the outside as 2. And what I'm going to do is I'm going to cut it down the middle. And I'm just going to cut it into half. And so the length at the bottom will be 1. And using Pythagoras, we've got to work out the length here. It's going to be 2 squared, which is 4, take away 1 squared, which is 1, will be 3, and then square root it would be root 3. So we know that's going to be root 3. So looking at labelling the sides here, just pick a colour to make sure it's nice. So we've got the hypotenuse here, we've got the adjacent here, and then the root 3 will be the opposite. And so we're looking for tan 60. So tan, as we know, is the opposite over adjacent. And so tan 60 is going to be the opposite, which is root 3, over the adjacent, which is 1 in our diagram there. So tan 60 is equivalent, it's the same as root 3 over 1, or just root 3. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.